All right, folks, another set of video notes here. This time we're talking about molecules and how we represent them using letters and numbers. So if you remember, a molecule, the formal definition of it is that there are two or more atoms that are chemically combined. The more casual definition is that anytime you have a chemical bond between atoms, we have a molecule. So remember that if we have a molecule that has all of the same element, or all of the atoms are from the same element, then we just call it an element. But if there are different elements within that molecule, we call it a compound. So what do molecules look like? One model that we use to envision what a molecule looks like is the sphere and stick models we have here. So notice each atom is a sphere, and then the stick in between them are the bonds that you might have formed between the atoms. So just as a quick glance at this, we have a bunch of different atoms here, and there's bonds in between them, so that's a molecule. Same for down here. These are a whole bunch of molecules that are in our air. They're really cool to talk about when you're in earth science. So how do we represent molecules? If you remember chemical symbols, we use to represent elements. They're one or two letters, and the first letter is always capital. The second letter, if there is one, is always lowercase. We kind of have the same system for molecules. So when we have two or more of those atoms together, we have to talk about the elements that are involved in that bonding and how many atoms of each element is in that molecule. So to do that, we use chemical formulas. A chemical formula is just a bunch of our chemical symbols, but they have subscripts next to the letters. They're little numbers next to the letters to tell us how many atoms of that element are in there. So like glucose over here, this is a picture of it. You notice there are 6 carbons and 12 hydrogens if you count them, and 6 oxygens. Well, we have C6H12O6 is the chemical formula. Same idea with butane and octane down here. There's 4 carbons and 8 carbons. There's C4, C8, and there's 10 hydrogens, so H10, and 18 hydrogens, so H18. A little bit of anatomy. We have the, if you notice, each capital letter tells us when we start a new element. So we have 2 capital letters here together. That's not one element SO, that is element S and element O. And we always start naming with the central atom first if there is one, and that'll make sense in a couple seconds when we start doing a little practice with it. But each of these little numbers, the subscripts, they tell us how many atoms of each element there are. So in this case, we have sodium, and there are 2 atoms. We have oxygen that has 4 atoms in this molecule. Then we have sulfur, but it doesn't tell us how many atoms there are. Well, that's because just like mathematicians, chemists can be lazy sometimes, and we don't write ones when we don't have to. So just like you don't write a 1 before a lone x in a math equation, we don't put 1 next to a lone element, because we know there has to be at least 1, otherwise we wouldn't put the element symbol in to the formula. So obviously, since we have this S here, there's at least 1 element, and there's not more than 1 because we don't have a different number here. We just have imaginary 1. Here's some practice that you can do on your notes worksheets, or need to do on your notes worksheets. I'll give you a hint for the first 3. This carbon here is the central atom. Notice everything is bonded to that carbon. So you would write C, and then you have 4 Cl's, which is chlorine, so you'd have CCl4. Same idea with this guy here. The boron is in the middle, with fluorines on the outside, and I would use carbon as your central atom here, even though it's not perfectly central. The most things are attached to it right here, and then tell me how many carbons and nitrogens and hydrogens there are. For these examples, there's a little key off to the side. So the white ones are hydrogen, the gray spheres are carbon, the red atoms are oxygen, and the blue atoms are nitrogen. So just count how many C, N, O's, and H's there are in each of these molecules and write down the chemical formula. If you have questions, be sure to ask me. And that is all for the notes video today.